Hi friends, today we're going to be solving equations with variables on each side. We're in chapter 3, section 5. Our vocabulary word today is identity, and basically you have an identity situation when you're solving an equation and then you get down to the bottom and you get something like 0 equals 0, or n minus 5 is equal to n minus 5, or notice it's kind of like the same thing on each side of the equation. Basically, when you have an identity, when you have something, both sides of the equation being exactly the same thing, right? Not even just being equal, because that's the nature, but being exactly the same thing. What that means is that the answer will be all real solutions. All real solutions. So think about it this way. If I gave you a problem and I said x is equal to x, now solve, children, you'd be like, what? And then hopefully after a while, after wondering about it, you'd say angrily at me, X can be anything. And it can be. And that's why all real solutions work when we have this thing, when we end up with an equation where we get an identity, the same thing on both sides. All right. So that's the only vocabulary we need to know. And let's go ahead and get started with our first problem. So we need to solve and check, and we know the deal. When you have problems like this, it's really important for us to make sure that we identify what side you want, like this is just to keep order, what side you want your p terms over your variable terms and what side you want your constants. It's just a helpful way of progressing through the problem. So on this side, if I want only my p terms or my variable terms, and I notice that both sides of my equation are already simplified, then I know that I'm going to get rid of this 2. I have to get rid of this 2 by adding it, by adding the opposite, right? So the opposite of a negative 2 is a positive 2. I'm left with 10p is equal to 8p minus, now I've got to add this. This is a negative 1 because of that minus sign. Remember, keep change, keep plus, right? Negative 1. Negative 1 plus a positive 2 is a positive 1. And so I get this, and now I only want constants over here. That means that this 8 has to get going. So I'm going to add a negative 8p to both sides. You see where this is going, people? And then I get 1, so 10p minus 8p is going to be 2p. So if 2p is equal to 1, that means that p, remember how do I isolate p? By dividing both sides by 2, because who's bothering p? 2's bothering p. How is 2 bothering p? By multiplication. What's the opposite of multiplication? Division. So I got to divide both sides. I get that p is equal to 1/2. Okay? So here's my checking part. I'm going to go back to the original problem, and I'm going to put in 1/2 everywhere I see p. Everywhere. So then, I think that was a minus sign. So then, I've got this. So negative 2, what is 10 times 1/2? It's going to be 5 because half of 10 is 5. What is 8 times 1/2? That's going to be 4 because half of 8 is 4. Subtract. Negative 2 plus 5 is a positive 3, and I get a positive 3 over here as well. So I know I've done a good job. Here we are with this next problem. I have it a little bit large, but basically they just want us to solve and check again. Again, the first thing I want to do is make sure I simplify both sides, which means freeing this expression from parentheses. And we do that by the fabulous distributive property. 4 times 2r gives me 8r. 4 times a negative 8 gives me a negative 32, or minus 32. And so I'm going to do the same thing with 1/7 times 49r. Well, 7 goes into 49 7 times, so the answer is actually 7r. And beautifully enough, 7 goes into 70 10 times. I can do 10 times 1. 7 goes into 70 10 times 1 gives me 10. And so this isn't so bad at all. Now that I've simplified this the best I can choose either side for my r term. I'm going to choose this side because I like to always put the r's where most of the r's are. If I got a lot of r's here, that's just my habit. It's not a thing that you must do. It is all to the good. So if I'm going to only want r terms here, who has to go? Minus 32 has to go. How do we get rid of minus 32? By doing the opposite and adding 32. What I do to one side, I do to the other. 8r is equal to 7r plus 42. I'm going to subtract 7r from this side because I only want constants here. And when I do that, I'm left with negative 7r. I'm left with r, which is equal to 42. And I'm done. Let's check it. Remember, when we check, we're just going to replace the variable with our supposed solution. And so that's all I'm doing here. 49 times r, which is 42. Golly gee willikers, what a big number. But we're tough, we can do it. Plus 70. And this is all in parentheses. Okay, so we've reached this point where we've gotten these two multiplied together is 2,058, and then add 70, we get 2,128, and now I'm hoping for the best, so I multiply 4 times all of this. 4 times 6 is going to give me 24. Drop that there. 7 times 4, that's 28. So 304, right? Is that right? What do you think? All right, let's check this out. So now I've got to divide 7 into 2128, or 2,128. So 7 goes into 21 3 times with no remainder. Can 7 go into 2? No, it does not. But can 7 go into 28? Yes, it does. 4 times. I know you're thinking, look at her fancy math. I would have just used a calculator. Please enjoy using mental math. It helps your brain grow stronger. I promise. All right, let's look at this bad boy. Here we have a situation where there's no solution. What does that mean? You're about to find out. We're going to simplify both sides of the equation. So this side is 2m plus 5. We're going to distribute. All right, Joe wants to tell everybody that he is present. Shh, shh, shh. We're going to distribute this 5 throughout, so we get a negative 35 minus 3m. We're going to join some like terms together. And when I do that, so remember I got to simplify each side, right? So 2m plus 5 is as simplified as possible. Here, 5m plus a negative 3m gives me a positive 2m minus 35. Notice anything weird here? Let's keep going. Let's say we want our m terms on one side and our constants on the other. Right now, your mathematical spidey senses should be tingling and saying something ain't right. So let's say I got rid of the 2m on both sides, like that. When I do that, I get that 5 is equal to 35. And right now you should be, or negative 35, you should be saying, wait, what's going on? What we have come up with, I know, my son is even upset, is a lie. This is a not true statement. This is a lie. And when you are doing math and you're working out a problem and you've made sure you've done everything correct, so I might go back here and say, wait a minute, I just wanted to move my m terms over here, but the m terms on both sides were identical, though the constant terms were not. Oh no. So you check your work, make sure everything worked out, and if you come up with a lie, you know you have no solution because there's no m in the world that's going to make 5 equal negative 35. So this is not true, and therefore, you have no solution. All right? All right, Joe agrees. Let's see if we can look at example 5. Here, example 4 rather. Here's a situation where we have an identity. We're going to simplify both sides of the equation. I know. By distributing 3 throughout. So we get 3r plus 3 minus 5 is equal to 3r minus 2. And then we keep going. We simplify this side because that's the first thing we've got to do before we start. First thing we got to do before we start. So 3 minus 5 is going to give me a negative 2. 3r minus 2 is indeed equal to 3r minus 2. I agree, Joa. But what did we talk about early on, way back in the beginning when this video started? We talked about this being a situation. Shh, you don't know the answer. We talked about this being a situation where we have an identity. It's like looking in the mirror. Yes, indeed, 3r minus 2 is equal to 3r minus 2. And I can continue by, let me move the 2 over, and I get that 3r is equal to 3r. And let me divide both sides by 3. And I end up with r is equal to r. I know. He's amazed and so am I. Okay, maybe not amazed. But when we have the same thing on both sides, we know we have all real numbers as the solution. And so the solution is r can be any old real number, and it'll make this equation true. All right, so here in this problem, we're going to finish up this section. And I'm going to try to hurry up before this baby totally takes over my video. So we're going to rock a distributive property to solve it. And so we get 2r minus 6 plus 5 is equal to 3r. I'm sorry, 3. I don't know where I got the r from, people. I think it was from the last problem in my brain, the baby and all that stuff. Okay, 3 times -1 is a -3. Better? Better. Good. So we're going to simplify this side. 2b minus 6 plus 5. We're going to join like terms together. -6 and a +5 are like terms. It's negative and positive. Subtract and take the sign of the higher. Therefore, it's 2b minus 1 is equal to 3b minus 3. And so if we continue on, I choose to put like my b terms, let's say over here, and my constant terms over here. It's not the usual way I'll do it, but I'll do it that right now, like that. I'm going to cancel these guys out. I'm left with a -3 over here. And then I get a -b minus 1, like that. So then I want my constants on this side, so I'm going to add 1 to both sides. And when I do that, I get -b is equal to -2. And so I see that the answer -2 is here, and I feel comfortable about myself. When we talked about this problem in class, one thing that I said was, whenever you have a standardized test, you take the SATs, PSATs, PSSA, whatever, and you are given a multiple choice problem like this, and you're not quite sure how to solve it, you literally can just plug in the variables and see which one works. And generally it's 1, depending on the situation, unless it's an inequality. All right, so with that in mind, I think I'm going to bid you adieu and look forward to talking to you guys soon. Have a good one, and I look forward to sharing another video with you soon. Take care, guys. Bye-bye.